This video recording is given a sample demo of our project. I am Niranjana and my teammates are Jaishree and SOWMIYA. My project title is Low Power and Space Efficient Build in Self-Test Architecture with the MSIC Test Pattern Generator. Abstract. This project proposes a low-cost test pattern generation scheme for a multiple single-input change test pattern based architecture. It allows one to optimize test coverage and test time during in-system test application. A test pattern generates MSIC input change test pattern that can be used to reduce the fault coverage in the built-in self-test. Introduction: The key goals in the design of VLSI, particularly portable system, are to reduce power consumption and unit area. Switching activity in the scan chain and test data compression using the appropriate TPG are essential during built-in self-test mode operation. The key goals in design of VLSI, particularly portable systems, are to reduce power consumption and unit area. An increase in space is achieved at the cost of more power consumption per exact processing unit. Objective: To reduce power consumption and area, an efficient MSIC test pattern is generated for enabling scan chain to prevent the occurrence of error during the transmission of data from one place to another to achieve fewer switching transmission using the specific MSIC test.
In the existing system, for generating effective weighted patterns, they used new low-power weighted TPG. Mathematically, to determine the fewest transmission, they implemented Galois operation because of the longest possible weighted patterns. A 32-bit TPG is implemented for gathering a low-power usage in all clock cycle and reduced area overhead. Drawbacks of the existing system. Drawbacks of the existing system is they used only one clock input that causes greater critical path delay from input to the output. Proposed system. In the proposed system, a new MSIC TPG for a scan-based architecture is used. MSIC testing is commonly used in the combination with other testing techniques to ensure comprehensive fault coverage in digital circuit testing. In advance, packet format analysis and classification should be conducted. The input data are sent to the receiver end, which is responsible for verifying whether the received data are correct or not.
This is the block diagram of our project. Consists of weight-enabled clock, weight generator, Galois operation, MSIC, and MSIC TPG output. Weight-enabled clock. The proposed weight-enabled clock is designed with some advantage, including fewer switching transition, achieving using the specific weight pattern, and reduced power attained using fewer hardware components in the design. This is reduced the hardware overload, improves the fault coverage in the BIST. Weight generator. The weight generator clock selection effectively reduces the fault coverage in terms of the random pattern resistor fault and the redundant fault. The test patterns are generated consequently using the shift register and the Galois operation. The weight enabled clock achieve one of the weight pattern to the weight generator. The weight patterns are mathematically calculated using the probability distribution. MSIC test pattern generators generate a minimum transition sequence, that is, it generates test patterns with change only in single bit position. The MSIC sequence produced by MSIC test pattern generator may contain repeated test pattern, but switching activity which result in an error is reduced. This the system improves the test efficiency. This method also reduces the power consumption during the testing mode with the minimum number of switching activities between the test patterns. MSIC TPG output. The stimulated output of the proposed MSIC test pattern generator. If the produced the test pattern of MSIC TPG gives the expected output of the circuit under the test without any error, a conclusion can be made that the test pattern generation. The Galois operation. Galois operation are used to achieve the maximum length in which weighted patterns with less switching activity. The proposed TPG includes a smaller number of components with a Galois adder and a Galois multiplier to achieve its weighted pattern compared with other TPG methods. Feedback: the TPG linear function is accomplished according to the output feedback signal and input feedback. The state of the register accommodated the multi-level parallelism in the TPGs. Its linear functionality are used in many applications such as aircraft system, cockpit system, medical system, audio and video system. Advantages: fewer switching transitions, TPG enhances its quick switching activity, reduced average scanning and capturing power consumption, improves the fault coverage. Conclusion: the occurrence of the error is prevented during the transmission of data from one place to another. Only fewer switching transitions are achieved using the specific MSIC test pattern. Analysis results showed that the MSIC sequence had a favorable feature of uniform distribution, low power transition density, and a low dependency relationship between the length and the TPG's initial state. The MSIC-TPG can be easily implemented and it is flexible to the test-per-test clock scheme and test-per-scan scheme.